Hi, everyone. I want to thank you for joining us for today's Visual Testing Master Class. Raja will kick off in just a few moments. We still have a lot of people in the process of logging in. So I'll give them a few seconds to settle in, and I'll take this opportunity to do a bit of housekeeping. So first of all, sound check. If you can hear me okay, raise your hand. You have a raise your hand option in the GoToWebinar control panel on your right. So just a quick show of hands if you can hear me okay. Okay, great, thank you. A few people participated, thank you. I'll take that as sound working. Questions. So Raja is going to go through about 35 minutes of presentation and live demo. You can ask questions during the session in the questions panel in the GoToWebinar control panel on your right. So ask away. We'll try to get to as many questions as possible at the end of the session. And worthwhile asking anyway, any question that we won't have time to answer during this session, Raja's team will answer later via email. So ask away. Another thing, since Raja will be showing a live demo, I do recommend you close off any unnecessary apps running in the background, just to prevent latency or delay between the slides and the audio. And you can view this in full screen mode. You have a zoom option to make sure that it fits your screen perfectly. One more thing, if you encounter any technical issues, my name is Adi, I'm the events moderator. You can contact me in the questions panel as well, and I will try to assist you as soon as possible. Okay, so I think that we have mostly everyone here. So Raja, I think that you can kick off.
All right, thanks, Adi. Hello, everyone. I'm Raja Rao. I'm the Director of Content and Growth here at Applitools. Today, I'm going to give you a quick demo of what Applitools is and why you need a tool such as Applitools in the first place, and what the problem is that you will find that you will encounter if you don't use such an advanced tool such as Applitools. All right, so let me go to the next slide. So let's first take a step back and understand what the problem is today in today's QA environment. According to a survey conducted by CA, 63% believe QA is the bottleneck in DevOps. 70% believe testing is still done manually. You probably have encountered this thing in your day-to-day activities. And 72% agree continuous testing requires a major shift in culture, because continuous testing is something that every company wants to do, but then again, testing is still done manually, so they can't really do continuous testing. So 72% of them say that there needs to be a major shift in, in culture. But let's take a step further back and then understand the reasons behind these problems. What's really causing these problems? Why are people thinking that QA is the bottleneck? So number one is the business expectations. So your brand experience is now digital. What that means is every company that you work for now have an app that needs to work and look really good in all sorts of different operating systems, all sorts of different devices, and all sorts of different browsers. So as a QA team, you need to ensure that your app actually works and meet those expectations, which is really, really hard. And it takes a lot of time, especially if you're doing manual testing. And the second thing is releases are expected faster and faster. Today, competition is greater than ever, right? So every company is outcompeting everyone. They're copying each other's features and so on. So the quicker they get the market share, the better it is. So they expect every team to be agile. They expect every team to deliver not only products that have all the features, but the features that really work well in all these different combinations, which means your QA team are expected to deliver all these things really, really quickly. So now, number two, the second problem is development and QA lifecycle hurdles. This is kind of a natural thing that happens in a lot of QA teams, or at least a lot of teams where you have a QA team that is separate from the development team. So if you look at a release cycle, so this graph kind of shows you a release cycle. The time is on the x-axis. A product development or a feature development happens in 3 phases. So the first phase, the product itself is being built. So usually during this time, the development is still happening. And a QA person, even if you are an automation QA person, if you go in and try to automate it, your developers and development team will say that, or a project manager will say that, hey, the product itself is not ready, so wait for it and do manual QA until it is ready. So that means this entire time you're doing manual testing, although you are supposed to be doing automation. And then phase 2 comes when the product is just ready, and you start automating, you start writing your automation script, but you still have some of the manual work needs to be done. Like it could be verifying some new feature, the feature is not ready or not fully baked. So you'll still be doing some manual testing. So by the end of the phase 2, you would have only covered about 30-40% in your automation scripts. I mean, this is quite natural because you didn't start when the development started. Whereas when it goes to production, let's say you were given like a couple of days time to make sure it is working in staging before it goes to production. Again, since you have not completed everything in automation, so you'll spend a lot of time in manually testing it. So the net is at the end of this cycles, you would have created only 30-40% of automation, and the remaining is all done manually, and the next cycle begins. Again, as the next cycle begins, since you had a lot of things left over, you still are kind of backlogged. So, and it gets only worse and worse and worse as the release cycles continues, and you are in like third release cycle or a fourth release cycle in your product development. And the problem number 3, the reason number 3 is what I call as a functionality bias, which is JavaScript bias versus CSS bias. So now if you take this login screen and if you ask a QA engineer to test this, they'll probably test if the username field exists, if the password field exists, and if the form works properly, if the sign-in button works properly, and so on. But they'll generally ignore if this logo exists, if the background image exists, if the alignments are all proper, and so on. This is especially true in terms of cross-browser testing, because where depending on the browser, the alignment may look bizarre, the alignment may break, or the image may not load and whatnot, but your automation script will not cache those things, and it may give you false positive or false confidence. Whereas if your CEO or somebody else may look at it in a mobile phone or in some other browser, they may say, hey, how come your QA team didn't find this logo missing or this alignment issue? Right? Because those are all not really functionality issues. They are really look and feel issues. So this is kind of quite natural. It happens because many of our tools such as Selenium, Appium, Cypress, and all these things are really, really good for functionality testing. They're not necessarily catered towards visual testing, right? So that's another aspect of it. So again, just to summarize, the reason why QA is kind of a bottleneck today is number 1, business expectations. Number 2, your development and QA lifecycle hurdles. And number 3, functionality bias. So that's really where Applitools comes in. Applitools is an AI-powered visual testing and monitoring tool. And what it is at a high level, it is just a plugin that adds AI capabilities and work with your existing testing tools and workflows. So it can work with your existing languages, like if your team is using Java, Python, Ruby, or any of the common languages, we have SDKs for all those things. And it works with any of your testing tools. We support pretty much all the major testing tools that are in the market today. And we also have integrations with a lot of your existing ecosystems, like Jira integration, GitHub integration, Jenkins, Slack, and whatnot. So, and we have tutorials for all these different combinations. So we have about like 40, 45 different SDKs, and we have tutorials for each one of them. So it's very easy for you to get started. And you're in good company. So it's not like we are a little startup and we are just starting it out. So we are sold to a lot of big companies, and they use it for some of their flagship products, and they run tens of thousands of tests every day. And they depend on Applitools at this point, especially to make sure their application look really, really good and in different browsers and different viewports and different mobile application, mobile phones, and so on. So what exactly Applitools do? Okay, so at a high level, it makes sure this kind of a bug doesn't happen. On the left-hand side, you see a little picture where the button looks nice. On the right-hand side, the button is probably functional. If you have written a Selenium test, you probably found the locator and you could click on the button and add to cart and whatnot. But then again, it's not looking nice, right? So it's not, it's broken, visually broken. So these kind of things, it's very easy for Applitools to find. So this is another example. So this is an example where this guy by name Yuan Yu, he's a very famous guy who built Visual Vue.js JavaScript framework, and extremely popular. So he is tweeting saying that Google, when they released their Pixel phone, if you look at the top bottom right corner here, their pre-order button is wrapped. Again, that's primarily because of the CSS issue. This is what I was talking about, the functionality bias versus the CSS bias, the JavaScript bias or the CSS bias. Because CSS is extremely hard because it is cascading. Any small little thing can cascade and cause problems somewhere else down the DOM. And it is extremely hard to find and detect. Especially it's hard to detect in different browsers because they all have slightly different nuances, and it's impossible to capture all those combinations. And this is the kind of things that Applitools can easily find and let you know before it goes to production. And it is hard. It's a really hard problem. And even for companies like Google, it's a hard problem to solve. So how do you actually use it? So let me quickly kind of give you an idea as to how you would use it on a day-to-day basis. So before Applitools, without using Applitools, today, if you are using Selenium or Cypress, so what you would do is you would use for every page, you would use those tools or their own validation to validate the page, and then also use them for navigation to go from page to page to page, and also for data entry. So you would use essentially those existing Selenium or Cypress capabilities to do all of them. Whereas when you use Applitools, you would delegate all the validations to Applitools. So page validations, you would simply say eyes.checkWindow or something. I'll show you what it is in a bit. So you'll delegate all the validations to Applitools. And then you will use Cypress or Selenium for data entry and also for navigation. So think of it like just entering some data and then clicking some buttons. That part you will do in Selenium or Cypress or any other tool that you're using. And then you will delegate all the visual aspects of verifying if something exists or not, and including every aspect of your page to Applitools. So essentially what happens is, because of your dividing and conquering, you'll suddenly have to write a lot less code, usually like 30, 40%, maybe 50% less code, and which also means that 50% less maintenance. And you will just simply delegate all those things to Applitools to verify all those bugs for you. And because Applitools is really good and it doesn't have any bias, you'll actually end up finding a lot more bugs with a lot less code ultimately. So here's an example of this. So here at the top, you are using all these. You're probably familiar with Selenium, and then you'll be using all these class names or IDs or expats to identify those locators. And since you will know, and because you're depending on all these things, you're kind of depending on developers' mercy. So if they end up changing any of these things, you'll have to go and then update this. And then not only updating is not just like going and changing the word in your test script. It also means you need to make sure you need to run it locally to make sure it actually works, and then check it back into your code. And before all these things happens, the test would have failed. So your developer would be saying that, hey, your tests are giving a lot of false positives and so on. So there's a lot of things that goes on when you depend on these kind of IDs, these kind of locators. Whereas with Applitools, what you would say is you'd simply use eyes.checkWindow, which is like an SDK that we provide that works with your existing Selenium AppM and so on. And since, as you can notice here, we are not giving any locators, it takes a picture of your entire screen, and then it uses artificial intelligence to compare that image with the future subsequent test runs image, and then it will tell you exactly where the problems are. And we don't really do pixel by pixel comparison. So you won't really find a lot of these issues just because of some small pixel changes like other open source tools provide. So we use a real AI, and we have trained our AI with millions and millions of images. So it knows exactly what a button should look like, what a menu should look like, and so on. So you'll get a very realistic, very accurate failure notification if there is any difference. So let me just show you how the code looks like, so you kind of get an idea of it. So this is a Selenium Java example. So if you were to use Applitools, you would first import our SDK. This is just a Maven code where you'll import our eyes SDK, and then you will initialize our SDK with our API key, and then you are going to start the test. So this is where you will provide the application name and the window name, and then you'll call our SDK's check window and give some name. Suppose you are testing your login page, you're going to say check window login page. And then once that line happens, ultimately you simply say ice.close, ice quit, and so on to end the test. So this is kind of, this whole thing encompasses one single test. And that single test has a single test step. So you can actually add multiple check windows. So suppose if you're navigating from login page to the app page and to some other page, so you can add ice.check window multiple times. And then in between, you can interleave Selenium's core navigation code, like button click and whatnot. And then you will have a single test with multiple test steps. So this is the code for Selenium JavaScript. So you'll again install Selenium JavaScript from our npm repo, and you are going to require our SDK, and you're going to initialize the SDK, and then you're going to say ice.open. This is where you start the test, and then you're going to say ice.check window to actually take the screenshot of that specific page, and then ice.close. So which means the test ends at this point. So again, notice that there is a very similar way you do irrespective of what SDK you are using. So this is a Cypress one. So here again, you are going to import Cypress SDK, and then you're going to say ice open, ice check window, and then here is an example where you're clicking on a button to go to the next page, and then you are going to again say ice check window to grab the picture of the second page, and then you're saying ice close. So this means create a test in Applitools where that has two separate test steps. And each time you call a check window, that becomes a screenshot. So Applitools takes a screenshot and uploads it into our server. And one thing to note here is the very first time you run the test, so now those screenshots become what we call as a baseline. Okay, and then the second time onwards, when you run the exact same test, so Applitools is going to compare the new test steps, the new images, which we call as a checkpoint, with the baseline images, with the corresponding baseline image. So just remember this one concept, which is the checkpoints are the brand new, the current existing test runs, and the baselines are the images from the very first test run. And if there is a difference, I'll show you in a bit. You can, let's say it's because of a real feature. Say you added a new button, and Applitools is now saying, hey, there's a new button that was not in the baseline, which means your first run. So you can simply click on a thumbs up button and then make the current test step as the baseline. And every subsequent test runs, it's going to now compare it with the new image. Hope that makes sense. Okay, if not, I'll give you an example. I'll give you a thorough demo so you'll know exactly what I mean. So that brings us to the demo so that I can go and then show you some of the capabilities of Applitools. And so that will make, hopefully it will make complete sense of why Applitools is so good and how the AI works. All right, let me switch to my dashboard. So this is what we call as a dashboard in Applitools. So dashboard is at a high level, think of it like this is where all the test results show up. And on the left-hand side is what you're seeing is a test run. So this is one batch test run, and this is another batch test run. So which is a test batch is simply a group of tests that were run that were simply grouped together using our SDK. And what you're seeing on the right-hand side are all individual test steps. And you can group them by, for example, test name. So you will see that this test batch had 2 different tests, and each of these tests had all these different test steps. Okay, and you can also group them by application. So you can group them by the app, and you'll see that this was run against a GitHub demo app. Okay, so now I'm going to show you another before I go and then show you how it works, I'm going to show you some of the capabilities of our AI itself. So I'm going to take an example where we have run the same some test against this USA Today, and let me make it kind of big enough so that you can clearly see this. So notice here, the left-hand side image is a baseline image, which is the first time when we ran the test. This was the image that was taken of the USA Today, and the right-hand side one is the image that was it's a checkpoint image. This is the current test, image. But then our AI is still saying it is a match. It looks like they both are obviously completely different, but our AI is still saying it's a match. That's because we are running this test in something called as a layout mode. So you can also see this by going here, and then you can see which mode is selected. So layout mode is one of the, we provide all these different modes, by the way. So layout mode is a way where we can instruct our AI to say that, okay, this is very dynamic page. So I don't want you to check for all the content. I just want you to check for the layout. I just want to see if these boxes are present, if all these things are aligned properly or not. If it's not aligned properly, then, I mean, just like for a human would judge, then throw me a bug. If not, make it as a pass. So this is an excellent example where you could use Applitools while your application is being developed. Okay, so if your application is being developed, which simply means that it's kind of dynamic at this stage, right? So you could ask your product managers and say, hey, I know the application is being developed, but I could run this, I can use Applitools and then run the test using in layout mode until it is ready for me to test in strict mode. So I'll talk about strict mode in a bit, but just so you understand that you could actually start automating your tests while your application is being built. Right, so and then it will only, at that point, it'll only simply check if all the, let's say the buttons and menus all exist at the correct location in different browsers and so on. And even just those checks may actually lead to a lot of bugs, where your developer is building something and then the alignment is wrong in some different browser and so on. You will be able to immediately find it and then let him know that, hey, this thing is aligned incorrectly according to Applitools, and then they will actually appreciate it immediately. So you'll get the benefit immediately, even when the application is being built. So let me take another example here. So this is another example of a layout mode. So here on the left-hand side is the baseline image that was run in different language, and the right-hand side is run in different language. Again, so this one we have marked as a failure, but oops, let me go back here. Where did I go? Oops. Let me see. So what I want to show is, although I have marked it as a failure for a different demo, but what I want to show you is that this specific thing is basically considered as equal. So you notice here this little equal sign is a match. So again, this is again because of the layout mode functionality. All right, let me go to the next one. So this is another example of what we call as a strict mode. So this is a PDF testing. Again, Applitools doesn't necessarily work just on a web application. It can work on PDFs. It can work on anything else, anything that can create a screenshot, that can generate a screenshot. Okay, so let me see. It's like internet is a little slow today. Okay, so here we are comparing. We are comparing the two different PDFs. So I don't know if you can actually see it properly. So let me try to make it a little bit larger. So notice here, I'm going to just toggle it. So you could see that in one of the baseline image, in the checkpoint image, the letter A in the logo of AT&T is missing, right? So similarly, you can zoom in and see all the other differences that are in the part of the part of this PDF. So let me see if I can show you somewhere else. Let me see. So this section is missing. So if I can toggle this thing, so notice that in the checkpoint image, this section, the label of this section header is missing. So again, all these things can be easily found using the strict mode. So you can strict mode can also be used in applications that are such as financial applications, where you want to make sure that the numbers and everything are accurate. So usually for PDFs and for finance applications, generally people, and also applications that are production ready, people use strict mode. So within your code, you can simply select what mode to be used. So you don't need to come to the dashboard to select it. So based on whatever you have selected in the code, that thing will be displayed in the dashboard. So one other interesting thing about our strict mode, our tool, is that suppose if there is something that is highly dynamic. So here, for example, over here, so this thing is highlighted. There is some difference here. So just say, for example, I don't care about what numbers are shown here because it's too dynamic. I don't want the test to fail just because this number constantly changes. So I can come and then select this thing as an ignore region, and then I can save it, and then it will automatically save that information. It will automatically ignore in the future restaurants. So the other thing I want to show you here is, let's say you found a bug. So let's say, for example, this is a bug. So you can come here and then you can literally select this section, and you can say this is a bug, and then you can create a bug, and you can fail this test, saying that okay, this test should be failed because there is a bug. And then you can also do some interesting innovative things like snooze this feature. So this is useful. Let's say when in some cases this is a known bug, and your developer or your product manager says, hey, this bug is being fixed. It will be ready in the next sprint, and it will happen in a week from now. So you can say that, okay, snooze this failure until until a week from now, and then save this. And if you and then you can create an issue in Jira until that point. But if that bug is not fixed after that date, then it is going to mark it as a fail. Okay, so it's pretty nifty feature that you could use as well. And so now I showed you the ignore region, and you can also do some other interesting things. So for example, so this test is run in a strict mode. So you could say, okay, although this test is run in strict mode, I want parts of this to be run in layout mode. You could say, okay, I don't want this to be ignored region. I want this to be run in a layout mode. So you don't ignore this, but make sure the layout of this section works properly. So here I am selecting this section to be a layout mode, and then I'm going to save this thing. So basically what it is saying is that, okay, so this section should be ignored mode, this section is layout mode, whereas the rest of this application should be run in strict mode. So you can kind of create all sorts of combinations within your app and make sure your test and kind of ensure your test doesn't give any kind of a false positive, okay, and ensure that your application adapts to your the dynamic aspects of your of the application under test. Okay, so that's very important, because we can't just make sure you can't, in a real world, your application may have some parts that are very dynamic, some parts that are strict, some parts may have advertisement and so on, which is highly dynamic. And so you need this flexibility. So we provide all these flexibilities for you to ensure you can create tests, and then you can create these checkpoints and ensure you can very easily manage them. So now I want to kind of move on and then show you some really cool feature that we just released, and one of them is called as auto maintenance. So typically what happens is, let's take this example here. So this is a GitHub application, and let me zoom in so you could clearly see what it is. Let's see, it's hard to kind of demo this thing because it's quite large of a page. So here, so what's happening here is that the baseline had this GitHub logo, whereas the checkpoint has the logo missing. So usually what happens is that in this case, let's say this is a failure. So let's say you came here and then you said, okay, thumbs down. But then the problem is, if you look at the second step here, even this second step is also failed because of that exact same bug, right? And the third step is also failed because of this exact same bug. So it's you probably already encountered something similar in your day-to-day work, where because of the some small bug, hundreds of tests fail, right? So how do you handle that thing? So that's where automated maintenance comes in. So you don't have to really go and then manage this thing on hundreds of these steps. So I can come here and then I can say that, okay, so this thing is a failure, so I'm going to mark this as a failure. And then immediately notice this at the bottom, our application now runs a background thread to see and search for similar differences in other steps, and then it will automatically mark those steps as failure, as whatever I said it here. So if I said it as a pass, then it would mark all those steps as a pass. If I marked this step as a fail, it will mark all those steps automatically as a failure. So this is what we call as an automated maintenance. So now that I marked this one step as a pass, so let me close this and show you. So notice that all these other steps that have similar differences have been marked as a failure. So now I'm going to show you, let me scroll down, and here there are a bunch of test steps that are still marked as undecided. So just so you understand, the undecided happens whenever there is a difference. So let's say, for example, the first time you ran the test, and that time it became a baseline. Second time you ran the test, but then there was a bunch of differences in the images, in the checkpoint image. So our Applitools will not mark it as a failure immediately. It will, the very first time, it want you to intervene and then manually accept which thumbs up, which means this is a new feature, which means it will automatically update the baseline, or thumbs down, which means this is a bug. So let's say what the problem here is. So here, let me toggle this thing. I'm going to disable this pink color, so just so you can understand. So here we have a baseline that is in black color logo, whereas the checkpoint that is a green colored logo. It looks like, GitHub, let's say GitHub is doing some kind of an experiment on their logo. So what we want to do is we want to not fail this, but we just want to ignore this and then mark it as a pass for the time being. So for that, I'm going to come here and then I'm going to mark this section as an ignore region. And then once I'm done with this, and then I'm going to say apply this to other steps in scope. So once I press this, again, the automated maintenance takes hold. And then what it does is it searches for similar images with green colored logo. And then it's going to mark all those things as ignore region for you, right? So and then all you need to do is once it is done, you're going to go ahead and then do a thumbs up. And then it'll automatically update that thing as well. So now that is done. So now it is select finding, again, similar steps, and then it's going to mark all those things as a thumbs up. So just so you understand, like, so now this specific test batch had about 80 or 90 test steps, and all I did was to update 2 separate steps, right? And then automatically it figured out and it searched for all the similar differences and did all the auto maintenance all by itself. So it's really, really powerful. If you think about it, like your tests may have hundreds of tests or even thousands of test steps. And all you need to do is to update 1 or 2 steps, and it will automatically update all the rest of it for you. So again, so now it is saying everything is resolved. Do you want to continue? I'm still going to say continue. And then now I can show you, if we scroll down, you'll notice that all these steps are marked as pass. All these steps are marked as a failure. So that's one thing that I wanted to quickly show you. And we also have this other feature called group by similar differences. You can click on this, and then it will automatically group similar differences by comparing all the test steps with all the other test steps, and it will group them if it finds similar steps with similar differences. Okay, it will take a little bit of some time, mainly because it is comparing all the differences and all the signatures of all the different images and trying to group all of them together. So that's why we have this new feature for automated maintenance where you don't even need to do this specific step. But I'm just showing you just so that you can see that this thing also exists. All right, so that's pretty much all I wanted to show you here. So I want to quickly go back and kind of show you go back to the problems that we discussed earlier and kind of tie it down. So again, the number one, business expectations are very high right now. You want everything to happen really quickly. You don't have any time as a QA engineer or a QA team, and there is a development and QA lifecycle hurdles and functionality bias. Let's take a look how all these things, how Applitools help with all these 3 problems. So number one, as you mentioned earlier, you are delegating a lot of work to Applitools, which means you don't have to do it. You are doing a lot of smart QA. You are becoming more like a smart QA team, like a smartphone, right? It's a lot more. You're delegating a lot of things, which means less code. You don't have to manage less code. You don't have to throw away a lot of code and rewrite them and so on. And enhanced coverage, again, because you are delegating to AI, it won't care about just the functionality. It will actually look at all the problems with the UI, and it will highlight all those bugs for you. And then whenever there's a new version, so if there is a new version comes out, you can just go ahead and then do a thumbs up, and you can automatically adapt your checkpoint image to the new version of your application. So which means, if you didn't have, imagine like if you didn't have Applitools, you would have to rewrite all those tests, right? I used to be a QA engineer. I had to do this all the time. So it was like just a nightmare. It's just an annoying thing. And it's not like you're writing something new. You just spend a lot of time writing these amazing test steps, and then suddenly you'll have to go in and throw it out or rewrite everything. So you don't have to do it now anymore because you never wrote it in the first place. And lastly, new QA automation lifecycle. So as I mentioned earlier, you can now start you are automating your application while it is being built. You can just use layout mode, and you can ask your product manager to have proper IDs for navigation, just to go from page to page to page. And as long as you have that, you can actually start automating your test even pretty much on day one, or a couple of days after the development starts. So that way you can be productive and you can start filing bugs immediately. Excuse me. And this is what all our current customers are saying. So they have reduced manual testing by 50%. Some have reduced by 90%. Some of them have reduced by 85%, and so on. Again, you can imagine this is quite natural, right? So if you're delegating a lot of things to something else, it has to happen. I mean, especially if that tool is really good. Otherwise, obviously, you'll have to again go back to what you're doing earlier. But we believe in it, and as I showed you earlier, a lot of big companies are using for their flagship products, and they wouldn't be using it, especially for their flagship products, if the tool wasn't working. And that's pretty much all I wanted to show you today. And I kind of want to quickly see, what time is it like right now? Is it okay? Okay, I'm going to quickly show you about this root cause analysis because it's really cool. I don't know if I have the example with me here. If I do, I would love to show it to you. Let me see if I can quickly change, or else I'll probably have to show you, or probably have to point you a video that I created some other day. I don't think I have it, unfortunately. So again, so basically, I want to quickly show you what it means. What I mean, although it won't work right now, unfortunately, is basically, let's see if I can automate maintenance. Maybe I can quickly show you here. So what it is let me see. So what it is you will basically select, I can't find a bug here. Let me see if I can find something that has a bug. I don't think so. I think I don't have the, okay, let me maybe this one. Okay, so I can show you quickly in this one. So here, what I'll need to do is I need to click on one of the bugs. So here, this is what we call as a root cause analysis. So what this is suppose you found a bug, a difference. You can now click on the difference, and then you can actually see exactly what changed in the DOM and the CSS. So what it is showing here is that for this specific login button, the tag name has changed. So all the red ones are all the red ones are the baseline, and all the green ones are the current version. So the tag name for this button is now button, where instead of an anchor, and the text is login instead of sign in, and its classes have been changed to all these things, and the CSS rules have changed to these things, and the bounding box, which shows you the size of the image, size of that particular DOM element, also has changed. So you can quickly see all these things, and then you can share it with your engineer, or as part of your bug report, and they can immediately see what the root cause for this bug was, especially from the UI perspective. So this means you are suddenly helping your developer be extremely efficient in their work, and then they can quickly go and then see what changed and then make those changes and then give you a high five, right? So that's root cause analysis for you. That's a really cool feature that we released in our previous release, and whoever has been using it have all liked it. So I hope that you also enjoy it. It's a really powerful feature. Take a look at it. I think it's free for next couple of months. If you're new to Applitools, create an account and you will get it for free for a few months, and then you can try it out. All right, with that, I would like to take some questions. That's pretty much what I had to say.
Great. So I'm going to take a second before we start with questions, and I just want to invite everyone that's attending to a special live session we're hosting with Selenium guru Dave Hafner. Dave is the author of the Selenium Guidebook and Elemental Selenium. So Dave will introduce the newly refactored Selenium IDE. and demonstrate its new capabilities and features. I've put all the info and registration link in the GoToWebinar chat room, so feel free to register and of course invite any of your colleagues that can benefit from this session. With that said, I'll give you the first question. So, is Applitools a standalone tool, or does it require extra tools, for example, Selenium WebDriver, in order to work properly?
Yes, it's not a standalone tool. So it is an SDK. So you would need Selenium, Appium, or any of these test runner. It's kind of like a plugin that you import as part of your Selenium, your test runner SDKs, and then you use it along with it.
What is the difference between Applitools and DOM-based testing, and does Applitools replace DOM-based testing?
That's a good question. So it is not a DOM-based testing. So usually DOM-based testing is where you take the DOM and then you compare the DOM with a new test run, and which can cause a lot of problems. But because as you may imagine, DOM is a very complex tree structure and can change very easily for any small reason, small changes by the developers. And so we don't really do DOM-based testing at all. So we just upload the DOM snapshots just for the root cause analysis feature that I showed you at the very end. And we just rest of the things are done purely by the image. So we just take a picture and then we compare the image using our AI technology.
Okay, I like that. Next question. How does Applitools deal with page elements that are not immediately loaded and need some time before they are shown on the screen? How does Applitools Eyes image capture work in those cases when the page takes a bit to fully load?
So the way you would usually do it is, and we provide all these APIs, but usually what you would do is, you would put the eyes check window exactly where when those elements appear. So you won't really do the check window before that, although we do have some logic inside our APIs to wait for some of the network calls to end. But still, usually what you do is you just wait up until all those elements show up and then do it. And we also have, let's say, if you're trying to take the screenshot of the entire page, we do scroll the entire page twice just to initiate some of these network calls, because some web pages have these lazy loading features, so they won't get initiated until you scroll down. So our SDKs automatically scrolls the entire page twice. So and then once to initiate it and a second time to take the screenshot and to alleviate this. But then again, it's pretty straightforward to do it, and there are lots of help articles as well around it.
Can I integrate Applitools results into my existing testing reports?
Yes, so we do provide, the SDKs provide all the results, so you can totally integrate this with your TestNG or any other tools that you are using for reporting.
Can we define a base image from an image, for example, JPEG, PNG, PDF, instead of capturing the baseline during the test run from a website?
Yes, absolutely. So we do provide what we call the screenshot SDKs. So which means you already have taken the screenshots, and then you can put all the screenshots in a folder, and then you can literally use our SDKs or screenshot SDK to upload them, and we consider them as a baseline. And then every time you want to compare with the new versions, you can take newer version of the screenshots and put them in a separate folder, and then you upload them, and then we'll compare the new set of images with the old ones. So again, all we need is a way to take screenshots. So all our Java, Selenium, and all these other SDKs are simply relying on Selenium to go to those specific pages so that we can take screenshots. And so there is no really, most of our work is around screenshots. And so we provide SDKs that are kind of bare bone that works with the direct screenshots as well. It also includes PDF testing. So if you have PDFs, you can import PDFs, and then we take screenshots of each of the pages, and then we compare that with the newer version of PDFs, like I showed you earlier.
Can I run my tests on Sauce Labs and get the visual validation using the Applitools Eyes SDK?
Yes, absolutely. Sauce Labs is one of our valued partners, and a lot of people use it. And it doesn't matter where the test run. So ultimately, it is just an API call from the Sauce Labs servers or from your local server to upload the image. So it will run the test as it is, and when the ice.check window shows up, it will just take a screenshot and also the DOM snapshot and then upload that to ICE servers.
And since we are out of time, one last question. My application contains sensitive information, which I won't be able to put on a public cloud. How do you deal with these types of security issues?
So we are really good with security issues. We are sold to a lot of customers who are extremely concerned about those things. So we provide, we also provide dedicated clouds and on-prem clouds and various solutions that will help you with these kind of situations as well. So just feel free to contact one of us, our sales members, and they will be happy to answer any of these situations. And we have seen all sorts of scenarios, and we have come out in flying colors when it comes to security.
We are out of time. I want to thank everyone that joined us today for our visual testing masterclass, and of course, thank Raja for this in-depth session. I do hope to see you all in our IDE session later this month. So again, you have the registration link in the chat room, and I hope you'll join us. So thank you very much.
All right, thanks everyone.